We all know renewable energy is great, but what if it could work all the time? Renewable energy resources are great for the environment and a carbon-free future, but one of the biggest challenges facing them is their lack of dispatchability. In other words, they produce energy only when the sun is shining or when the wind is blowing. Long-duration energy storage technologies have the capability to transform renewable energy resources from non-dispatchable to dispatchable resources and modernize our grid. But if they're so great, why aren't we seeing more of them on the grid? IRPs, or Integrated Resource Planning Studies, don't know what LDESs are. Wait, what are IRPs? They are studies that utilities conduct to find the right mix of energy generation resources to meet the growing load on the grid. Back to LDESs and why we're not seeing more of them. IRP studies and simulations only model lithium-based systems, not just as a technology, but also the use cases or the dispatch profiles that lithium systems can support. Primarily, 1 cycle a day, short duration applications. So these dispatch profiles, while they're very advantageous for lithium, may not be the most suitable for LDES technologies. We really love analogies, so here is one for this example. What IRPs are trying to do is like slicing a loaf of bread with a hammer. If you run an IRP simulation with just lithium and lithium-based applications, it's like trying to cut a loaf of bread with a hammer, the hammer in this case being LDES technology. You can't say, oh, hammers don't work. The only reason hammers aren't cutting the bread is because it's a tool built for a different application. Building a deck, on the other hand, would be a perfect application for a hammer. An example of a suitable application for some LDESs would be 2 cycles per day applications. For instances where you need to cut a loaf of bread and build a deck, you need both the knife and the hammer. Going back to BESSs, you need both lithium batteries and LDES for these different applications. For example, single cycle and multiple cycle per day applications. Well, what's the apparent solution? Accurate modeling of LDES technologies allows us to uncover their best applications. This will in turn result in IRP results that are more open to longer duration technologies, using them where they perform the best and where they're most needed. We know you want a practical example, here is one. When Storlytics, a software that can be used to model both lithium batteries and LDES technologies, was used to model Enervenue's nickel-hydrogen vessel batteries, we found that compared to lithium LFP, it's actually much cheaper from an overall cost of ownership standpoint to use Enervenue and LDES in multiple cycle a day applications. So with Storlytics, you can create an accurate model for different LDES technologies, and then you can find the best usage of that technology because you have that model. You'll then try a bunch of different use cases and find the one where it works best, saving you millions of dollars and years in pilot projects. As the LDES Council annual 2024 report states, LDESs are essential for decarbonization and they need to scale up to 50 times faster than is currently projected. Accurate modeling and IRPs implementing such modeling may prove that that's possible. Here's to LDES having a brighter future! Check out Storlytics for its accurate modeling capabilities.